Hello everyone, and a very nice and warm welcome to the session. My name is Govind. I represent GlobalSign. I'm part of the sales engineering team based out of the Maidstone office. For those of you who already don't know GlobalSign, we are a publicly trusted certifying authority, which in short means that we are in the business of issuing online identities. Now, these identities are of different types, and the technology that we run on, we'll talk about that as we go forward. The topic for the session is fully automated, scalable PKI solutions for mixed enterprise environments. So mixed enterprise environments basically mean when you have different types of operating systems, different types of devices, endpoint servers, mobile devices, how does it really work? In the session, we'll talk about two of the biggest challenges when it comes to implementing PKI. And we'll talk about what is PKI. We'll go into the very basics of what is PKI. Automation is one of them. How do we automate PKI implementation, and how do you do that on cloud in SaaS? There are a lot of on-prem implementation options. And then at the very last is PKI best practices. So just by having PKI itself is not enough. There are certain best practices that we should follow, and we'll talk about that in detail as we go forward. So to kickstart the session, I would like to touch upon three very basic information security concepts, which I guarantee everyone here knows already. But just in case someone is not, I would like to quickly touch upon. The very first and the most important is authentication. And few of these concepts also touch upon the IoT side of the things. So today will be focusing, in this session, we'll be focusing more on the enterprise side of the requirements. But then on the IoT side of the things also, few of these principles touch upon. So the very first is authentication. Authentication is a process by which you prove or authenticate yourself to the relying party, the servers. You prove who you are. Encryption is when you have established a communication channel, you encrypt the data so that no one can read it. Simple. Data integrity is when the data has already been compiled, composed, prepared, so no one should be able to tamper it. Simple. There are different techniques through which you can achieve all of these three. In our opinion, in GlobalSign, what we do, and in my personal opinion, the best way to do that even today is PKI, public key infrastructure. So let's spend a couple of minutes to quickly understand what PKI is. And again, I'm sure most of you would know what PKI is, how does it work, but just to have a quick overview. So in the world of PKI, every entity like you and me will have three objects. There's a public key, there's a private key, and there's a certificate. I, as an end user, will generate a key pair. There's a public key, private key. I keep the private key to myself. That's what the name says, private. The public key goes to the CA. CA could be a publicly trusted certifying authority like GlobalSign, or it could be your on-prem, self-hosted, self-signed CA. And then the CA vets me as an individual user. It could be me, it could be a device, it could be anything. And then a certificate is issued to me. These three objects combined, the public key, the private key, and the certificate, is basically my identity. And that's the beauty of PKI. The beauty is that you can split the identity into two parts. There's a public key and there's a private key. There's a private component, there's a public component. No other technology that I know of can do this. So the disadvantages with other technologies is if it's a password-based approach, it's any form of pre-shared secret, and then lots of other technologies that depend upon these pre-shared secret concept, is that there's only one form of identity, the pre-shared secret, that is there with you and it has to be with the server. But with PKI, you keep the private component to yourself and the public component goes to the entire world. And then when I have to authenticate myself, I basically log on to a server. The server probably will already have my certificate because it's the one who issued me the certificate. And then I have to prove that I hold the corresponding private key. And there are various ways of doing it depending upon how you implement the solution. So this is how I authenticate. Using the same set of keys, I can then digitally sign and even encrypt the data. You can use PKI for various different use cases: server security, user and machine authentication, email encryption, document protection, network security, and it goes on. And as I said, in IoT space, IoT lies somewhere in between server security and network security because we're talking about devices. So coming back to the PKI implementation and the hurdles, these are the two most important concerns that organizations have. How to provision and install certificates to different endpoints. So PKI is good. We just discussed PKI is one technology that is worthwhile evaluating. But the challenge is, how do you actually roll out the solution? Once you have issued the certificates, how do you manage the lifecycle management? So there are concerns. Let me talk about more concerns, then we come to the solutions. In the modern enterprises, we no longer have just one type of operating system. Most of you would be using Windows, Linux, Macs, different types of web servers, Apache, IIS, mobile devices, MDMs, network devices. How do you manage certificates? How do you manage the identity of these devices? So these are the challenges. Provisioning. So I would like to touch upon very quickly on one of the most commonly known mechanisms of doing that, which is pretty much a de facto standard. It's called Microsoft CA. Why Microsoft CA? Because it comes free with Windows servers. And over the last couple of decades, this has become pretty much a standard. The moment you think about hosting an on-prem CA, the first thing that comes to your mind is Microsoft CA. And people believe that it's free. It is free, actually. The software is free, but there are a lot of cost elements associated with that. The font might be a bit small for you to read. Anyways, I'll try to still explain. So there are various different cost components. Starting from the very top, you have HSMs. Again, it's dependent upon your implementation. If you really have HSMs to protect your keys, not many customers do that. And the customers who do that only think about using HSMs to protect the root keys, the root of trust. Not many customers. There's only one customer I've met in the last about 2.5 years who actually went below the root of trust and thought about using HSMs to even protect their issuing CAs, and even going to extend to protect your SSL keys. Let me ask the question over here. All of you would be having secure websites in your organizations. How many of you have ever thought that the SSL certificates that are issued also has a private key, and you need to protect that private key? It could be a rogue administrator who has access to the web server, gets the certificate, gets the private key, goes outside, launches a phished website, and then your identity of your website is basically with him. So he becomes your website. Anyone here has thought about it? Awesome. Great. Good to know that we have some who have thought about it. Not many do that. So that's a concern. That's where we say HSMs are good to have, but then there's a lot of cost associated. And I have something at the end of the session which might be of interest to you two gentlemen, which will help you protect your SSL private keys on your web servers without the need of an HSM. Other cost concerns are you need a team, set of people who can manage, implement, run the show pretty much on a day-to-day basis. If you have a DR, depending upon what DR capacity you have, the cost replicates over there. So a 5-year TCO, depending upon whether you have compliances, any sort of compliance, certificate policy, certificate practice statement, XYZ, the costs can vary between anything on a 5-year TCO, depending upon how you do it, between $500,000 and $1 million or $1 million plus. Also depends on the volume of certificates, as you can see, the root of trust, depending upon how many public trust certificates you have. You may not have a need of any public trust certificate, by the way. So the solution to the challenge of on-prem CA is one of the offerings that we have is called Auto-enrollment Gateway. So it's a pure cloud alternate to any on-prem CA. Think about AEG, the Auto-enrollment Gateway, as a connector between your environment. And we're talking about Windows environment. That's why you see Active Directory. We have other offerings which can be deployed in a non-Active Directory environment as well. But just as a use case, we'll be talking about AD. And this solution allows you to issue certificates from the GlobalSign SaaS CA, and the certificate issuance, the lifecycle management, the compliance, the security policy, the audits, all of that is with us. So you get the exact same end result that you would get with an on-prem CA without the burden of having an on-prem CA. So the good part is it leverages your existing environment. It sits on top of Windows Active Directory. You don't need to have a new repository in place. It can simply sit in and it can be live in just a couple of days. Literally a couple of days, you can go live. So this is what it looks like. On the left-hand side, you have your environment. AEG is somewhere in the middle. That's basically a connector, and it can be deployed on a desktop-grade machine. You don't really have to have a very high-grade server for that. And then it connects to various different devices. It supports various different protocols like ACME, SCEP, XCEP. We have MDM integrations as well. And on the extreme right, you would see GlobalSign SaaS CA. That's where we basically go and issue the certificates, manage the lifecycle. And A quick TCO comparison. So with on-prem CA, you have these challenges: software, hardware cost, implementation, compliance costs, multiple teams, and these get pretty much reduced on the right-hand side because it's all happening in cloud. So further few advantages: it's a reduced IT administration, as I already discussed. It's very easy to understand. It's like any other cloud solution that your IT costs, administration costs go down. The middle point is very, very important. When you go on cloud, specifically to identities, the technology we deal with, your risks go down as against going up. When this normal notion that when I go cloud, my security is going down. It's not really the case. Because when we issue certificates to you, we do it with proper audits. We are under WebTrust audit, under CAP forum compliances. We have our own certificate policy and practice statements, which are publicly available. We run on HSMs, protect the issuing intermediate, all the keys on an HSM. So the compliance, the security goes up as against going down. So that's an advantage. The use cases, so we can issue public trust certificates for SMIME, PDF signing. We can even issue private trust certificates for your client auth, machine auth, IoT kind of use cases. You have role delegation, reporting, logging capabilities, which come standard, ease of management, and obviously we are based on the GlobalSign's highly available and secure world-class infrastructure. So what we are saying here is that generating certificates and issuing certificates to your devices, to your laptops, desktops, blah, 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 doing it on cloud is no different than what people have been doing for the last 20 years to get their certificates, SSL certificates from a CA, which has been happening in cloud for the last 20 plus years. So what we are saying that can be extended from just plain vanilla SSL certificates to different types of certificates. So that's the message over here. Okay, so the very first section we discussed, PKI is one technology that is worthwhile evaluating for your various different identity needs. We discussed the hurdles and what are the possible solutions to that. But what I strongly believe in is by just having PKI is not enough. You need to implement PKI with the best practices. Now, the best practices are that private key, as we discussed earlier, is my actual true identity. You need to protect the private key across the hierarchy. Not just the roots, not just the intermediates, not even the issuing CAs on your endpoints. Endpoint could be a web server, it could be a device, it could be a desktop, it could be a laptop. You need to protect the private key everywhere. If you don't do that, that becomes your weak link. So private key protection is extremely important. Now, there are techniques which exist today to protect the private key. I'm not talking about software key stores which exist by default, which is very ubiquitous in all the operating systems, which are called software key stores. They are pretty flimsy and then can be breached and keys can be skimmed. The secure methods, conventional methods, are smart cards, tokens, which everyone here knows. Most of you would be using smart cards. TPMs, Trusted Platform Module, it comes as a chip embedded into your motherboard. It's there on your devices. Not every device has it, by the way. Most of them have. And then, of course, HSMs, Hardware Security Modules. So HSM is a very nice way to secure your keys, but it's only nice if the keys are all on the server side. You're talking about issuing CAs, intermediate CAs, web servers, stuff like that. What happens if the keys are required on the endpoint? You cannot, it's a very bad idea to keep endpoint keys on the server. If your use case is authentication, you need the key to be available right here to be able to authenticate itself. But there are use cases, by the way, where you can keep end user keys on an HSM, but it's not very scalable. So, today I'll be talking about one of the very unique offerings that we have. It's called software-based PKI containers. And that's the last point for my session today. So this comes to us through one of our technology partnerships with a vendor. And this technology is called IC Metrics, Integrated Circuit Metrics. What this technology does is that it captures the digital fingerprint of the device, let's say this device, and then it converts, it uses, there's a technology, which I'll show you how it works, and then it gives you a key based on the digital fingerprint. Now, the digital fingerprint comes from some of the hardware parameters and some of the software parameters. And the way this technology has been designed and stabilized for the last about 14 plus years is that it can identify a device very, very uniquely amongst billions of devices. If you have two such devices manufactured by the same vendor, I can identify those two devices, and I can guarantee that the key issued over here won't work if it's working outside, if it's been taken outside or skimmed outside. So this is how it works. So there's a device which wants to identify itself. There are certain parameters which we read, hardware components, let's say. It could be an antenna of this device. It could be RAM, memory allocations, various other hardware components that can be picked up. There are software components also that can be read, firmware version, BIOS version, blah, blah, blah. And then we run them through, we basically normalize them. That's called normalization. In normalization, what we do, we identify the parameters which are stable enough to give you a key that can be repeated. So you want to have the same key again and again. There are situations where you want to have a different key, short-lived certificates, different keys can be done. Most of the use cases, you need the exact same key on this device. So what we do with this is that we are not storing the private key on the device. As and when the key is needed, it is generated, it is used, and it is discarded. We don't store the keys anywhere, unlike what you do with conventional software containers like P12 and PFX files. We use some normalization maps to further refine the value, the key value, and then we reduce noise. So when you are running on a hardware components, there is noise. There's some hardware which is running inside, right? You could have noise, arbitrary noise, random noise. So we then remove that basically, so that we then get a stable key. Now this key is the same key pair that I was talking about earlier. So when you generate a key pair, you want to have very high level of entropy so that the private key is unique. Now, the way this technology works is that if there's a client which sits on all the devices. If it is copied from this device to the next device, you won't get the same private key on the other device because the hardware and the software parameters have changed. One additional point, very, very important point about this technology is since it runs on some software parameters, it even has anti-malware capability. Now, the technologies that I spoke about earlier, hardware, smart cards, tokens, even HSMs, PPMs, none of them give you an anti-malware capability. What do I mean by anti-malware? So when you have a smart card or a token, if a malware takes over your device, the malware then does what it has to do. And you probably would not even know there's a malware sitting and it's authenticating on your behalf. It's basically executing a transaction. Since this technology reads software parameters, it can understand when a malware has infected your machine and there's something changed about the device characteristics. So this is what is very, very unique that we would like to offer. And this is the point that I was talking about earlier. You can use something like this to even protect your SSL keys. Not just your SSL keys, even your SMIME, your document signing keys, even your client and machine auth. Client and machine auth certificates or those private keys are basically self-signed, most of the cases. So they don't have a public trust, but still they're equally important to you as a customer because your endpoints depend on these keys. So you can use something like this on pretty much any endpoint and you can secure the private keys, you can secure the identity. So I would like to quickly summarize the way the whole the flow goes is that you need to first identify, and this is the last slide by the way. So you need to identify what are the pain points that you have. GlobalSign as a vendor is there to help you when it comes to strong, trusted online identities. There are many information security concerns. We don't do everything. We do identities. We do trusted identities. We have provisioning engines. The one I spoke about today is just one for your Windows environment. There could be non-Windows environment. There could be completely different set of devices. We have API-based approaches. And then not only we give you PKI certificates and identities, we can do it via best practices. And that's what I just spoke about. So that's pretty much it for my side. And I think we have good 4 minutes for any questions, if there are any. Otherwise, we are at booth 1240 for any questions offline.
Thank you for watching this GlobalSign presentation. For more videos on identity and PKI, follow one of the links on your screen. And don't forget to subscribe to our channel to keep up to date with the latest video content.